everyone, it's Justin again. In this lesson, you're going to learn about some relationships that exist when we draw in special segments within similar triangles. By the end of this lesson, you will be able to solve for unknown values involving the medians, altitudes, and angle bisectors of similar triangles. First, we'll learn what the relationship is between similar triangles and each of their special segments. The special segments we'll be referring to are medians, altitudes, and angle bisectors. Then we'll complete one example problem. There are three types of special segments we're going to look at in this lesson, and the first is the median. Let's explore the relationship that exists with the medians of similar triangles. Here are two similar triangles that are oriented the same way. Next, let's draw in a median on each of these triangles. Do you remember what a median is on a triangle? A median is a segment that joins a vertex to the middle of the opposite side of the triangle. If I draw a median on each triangle from vertex N and vertex Q, it would look like this. And let's also add in some more labels here. Now keep in mind that there were two other possible medians we could have drawn in each triangle, and that would have been okay too. We just have to make sure the medians we draw extend from corresponding angles. Anyways, the fun fact here is that the medians actually have the same ratio that the other corresponding sides of the triangle have. We could say that the ratio of the medians equals the ratio of any of the corresponding sides of the original triangles. The ratio of the medians equals the ratio of these two corresponding sides. And also these two corresponding sides. And these two. Here's a summary of this concept with two similar triangles shown oriented the same direction. We have A and B representing corresponding sides of each similar triangle, and X and Y representing the special segments, which in this case is the medians. But we could also set up the ratio with these corresponding sides from our original triangles. And the final pair of corresponding sides would work in the proportion too. Any pair of corresponding sides can be written as a proportion with the medians. A similar relationship also exists between the next special segment of similar triangles, the altitudes. Do you remember what an altitude is? An altitude joins a vertex to the opposite side at a right angle. Here are two corresponding altitudes in these triangles. And there's a proportional relationship that exists here, just like the one we explored earlier. The relationship this time is between corresponding sides of the triangles and the altitude. We can set up a proportion in the same way we did a moment ago, using corresponding sides as A and B and our special segments as X and Y. These corresponding sides fit into this same proportion, and so do these. Let's talk about one more special segment within similar triangles. Here are those same similar triangles again, and here is an angle bisector on each of them extending from corresponding vertices. Can you guess what the relationship is this time? The relationship this time is between corresponding sides of the triangles and the angle bisectors. Could be set up like this, or using another pair of corresponding sides, like this. Or with the final pair of corresponding sides, like this. And as always, remember that for these proportions to hold true, the triangles we started with had to be similar in the first place. Now's a great time to catch up on your notes template before we complete an example problem. Pause the video now to make sure you're ready to continue. Let's do a practice problem. This says, given that triangle ABC is similar to triangle DEF, solve for the unknown variable. I made a little list for us to use just to make sure that we can confidently answer questions like these. First, let's make sure the triangles are similar. Do we know these triangles are similar? Yes, we were told so in the directions. Do we have either two corresponding medians, two corresponding altitudes, or two corresponding angle bisectors? Yes, we have corresponding medians. There's one final thing to check before we solve. Do we have two pairs of corresponding segments labeled? I see both medians have a measurement associated with them, and these corresponding sides also have a number, or variable, attached to them. Okay, now that this problem checks out, let's go ahead and solve for the unknown. Go ahead and set up a proportion and solve it. Pause the video and do it now. Go ahead and check out my work here. Hopefully, you also got 13.12 as the solution for n. If not, pause the video here and see if you could figure out what went wrong. Now you know how to solve for unknowns when similar triangles contain corresponding medians, altitudes, or angle bisectors. See you next time!
Hey.